3, 2, 1.
In this video, in Practical Tips for Rocket Engineering, we have a closer look on ball valves. We use ball valves in our pressure systems to ensure fluids and gases are flowing in the right places when we want them to. We're going to talk about the manual activated ball valves. So there are lots of different types of ball valves, but effectively you will have a main body of the valve, you will have a handle, and then some form of connection ports. Okay, here we have a standard sort of swage slot connection ports. Sometimes you might even have valves with multiple ports upon them. They could be quite small, or indeed they could be quite large as well. Most of these manually operated valves, okay, are 90-degree turn valves, but you can get others which turn 180 degrees, especially if you're using multiple ports like this. So that's a 3 different positions. So position 1, position 2, position 3. One of the things that we have to think about when looking at ball valves is effectively the hole size, the bore size that we have through the valve. Now, different valves will have different bore sizes depending on what you specify for them. Okay, so you could have sort of medium-sized ones, you could have extremely small bore sizes, and then you could also have fairly large bore size. The bigger the hole size or the bore size that you have going through your ball socket joint, the less of a pressure drop you're going to see in your system, and also the larger holes will allow you to have much more flow. If you are putting a large flow through a valve which isn't designed for it, you could get quite a lot of flow effectively going through a very small area, okay, leading to a restricted flow, effectively leading to a significant pressure drop in there. So choose your ball valves wisely. Now, the other thing that you need to think about is actuated ball valves. So for solenoid valves that you might actually use on a flight system in space or on a launcher, okay, they can be fast acting, but they're also very expensive with very long lead times, almost potentially up to 9 months lead times. With ball valves, they're relatively inexpensive to make, okay, and they are readily available as well. But the main difference with a fast actuating solenoid valve and a ball valve where you may have an actuator placed upon it, which will then effectively rotate the handle effectively for you, okay, is that it will take some time to do it. In our experience, somewhere between 5 and 15 seconds to rotate that handle around. So think about that delay in time when you are setting up your firing schematics or your firing schemes, okay, in your actual propulsion testing. So getting the timings right when using automated ball valves, okay, with actuators on top of them, okay, can sometimes be a bit tricky. Okay, thanks for listening to this word of warning. If you like the video, please like and subscribe.